So a magazine producer can sell $600, sorry, not $600, 600 magazines if it was $6 each. Okay, a marketing survey shows, so you guys know what a marketing survey is? It means they somehow ask a group of people and they answered like, oh, you know, if you increase the price, maybe I wouldn't buy, and so on. Okay, so that's what marketing survey is. And that survey said for every 50 cents that she increases, she will lose about 30 sales, according to the survey. What price should she set to obtain the greatest amount of income? Okay. So the income, right, is generated this way. It's number of magazines, okay, number of magazines she sells, times by unit price. That makes sense, right? It's like if you sell 100, how much do you make? 100 times by the cost of each particular unit. Now this question is saying the following. So we got to convert this into a quadratic equation, okay? It's saying, so number of magazines. Initially, she can sell 600. Okay, if the unit price is set to be $6. Now it says if she increases the price by 50 cents, so 0.5. But we're not saying she's going to increase the price by 50 cents. We're going to increase the price by some multiple of 50 cents. Or maybe we'll decrease it by 50 cents. Right? We want to find out like at what price should she set so that the multiplication of these two is maximum. So let n represent number of price increase. Okay, so does this make sense, this formula here? 6 plus 0.5, and that's number of, this represents how many times she increased the price by 50 cents. So this is the expression, algebraic expression of her new price. Okay, I don't know, we're trying to find out what n is. But every time there's an n, every time there's a plus n, there's going to be a decrease in number of sales, and it's 30. So number of magazines sold, if this represents unit price, it will decrease by 30. Does that make sense? So this is your new price. I don't know what finding the n will determine what the new number of magazines will be and new price will be, but this is how we express it when we don't know what it is yet. And they have to match up like this, right? So this says every 50% she increases, right? Plus 50, she loses 30 sales, minus 30 n. So let's actually do an example here. Let's plug in 1, n is equal to 1. The unit price will increase by 50 cents, so it's 650. Does it give you 650 if you plug in 1 in there?
Yeah.
Then number of magazines, it should decrease by 30. Now, does the formula actually decrease the number of units by 30?
Yeah.
Yes, it does. Right, so it's 570. So you're going to multiply these two to get how much she makes. Now what we have to do is go back to this formula of income. Okay, income. Now instead of number of magazines, number of unit price, we replace that with our algebraic expressions. Like that. And doesn't that look like a quadratic equation? It does, right? It's factored. So look, you can factor out 30 further from there, and you get 20 minus n. You can factor out a 0.5 from there, and get 12 plus n. Okay, so from here, this translates into the x-intercept, right? And when n is equal to 20 and negative 12, the income will be 0. So if you do a graph, it looks like the following. Minus 12 and 20. The midpoint is going to be our magical maximum income number. So what's the midpoint of 20 and minus 12? It's 4, exactly 4. Okay. So when n is equal to 4, income is maximized. So what does that mean? That means, yes, price should be increased to 0.5 times by 4, which is $8. $8 will give her the maximum amount of money, income. Okay. And the income will be, I guess I can plug in. Okay, so the max income is 600 minus 30 times by 4, which is 120, and that's 8. So it's, 480 times by $8 is the maximum income she can get according to the survey. Okay, so that's the maximum income.